Alright, so moving on to the module about confidence intervals for means. Alright, if you haven't done so already, go ahead and print the t-distribution table. You should know how to find critical values using the t-distribution table. So let's go ahead and do that first. We have a 98% confidence interval. Sample size is 9. We want to find the t-critical value. Now over here it says degrees of freedom. Degrees of freedom is 1 minus the sample size, right? So in this case it would be 9 minus 1, which is 8. So go to the row that says 8. Now the area in two tails is the area that's left over from your, so you have 0.98 in the center. So the area that you have left in your tails is 0.02. Okay, so there it is, 0.02. So we find where those two meet. The area in two tails, right? We're only going to use this area in two tails for this section for confidence intervals. Okay, and we get 2.896 as our critical value. Alright, let's practice using that t-table and know how to use it and answer questions like this. Alright, moving on, next question. A survey of 62 college students found that the average number of hours spent playing video games per week was 21 hours. Okay, so we sampled 62 college students. We found that on average they spent 21 hours. And the standard deviation was 4.5. Now why did I write sigma? Well, sample size is so big that the sample standard deviation is going to be really close to the population standard deviation. So we can make this assumption when you have large enough sample size that you can assume it's basically the same as having known the population standard deviation. Okay, what's big enough? Different people use different cutoffs. In this class, we go ahead and use the cutoff of 30. All right, as long as the sample size is more than 30. Okay. Find the 90% confidence interval for the mean number of video hours spent studying or spent playing video games. Okay. So if I go to my formula, I'm doing confidence interval right now for a mean. So I'm using this one. Now, am I using sigma known or sigma unknown? Well, because my sample size is big enough, I'm going to use sigma known. Okay, if my sample size was small, I would have to use this one. Okay, so let me go and write this down. All right. Now, z alpha divided by 2, that's the critical value for a 90% confidence interval. Alright, so that means 90% in the middle. I'm going to draw this up here. 90% in the middle, this is the z distribution, which leaves 0.05 for each tail, which means that the area below this value here is 0.95. So I look for 0.95 inside my table. Alright, it's directly between these two, 0.9495 and 0.9505. So it's 1.645, which is one of the really common values. That's why it has a little star, and it says and it's also over here that if your confidence level is 90, then your critical value is 1.645, which is also right here. Okay. So this should be 1.645. Okay. Sigma is 4.5. N is 62. Alright, let's go ahead and calculate that out. 1.645 times 4.5 divided by second, so square root of 62. Okay. Alright, so then I'll do 21 minus that margin of error. And 21 plus, oops, I wrote down minus, that should have been a plus sign, that margin of error. Okay, so 21 minus that is 20.06, and let's see, 21 plus the margin of error is 21.94. Okay. So we're 95% confident that the true population average number of hours spent playing video games is between 20.6 hours and 21.94 hours. Alright, moving on. A doctor wants to estimate the average BMI of Americans in their 20s. Doctor knows from previous studies that the standard deviation for BMI is 3.2. Doctor wants to be 99% confident that the estimate is within 2 units of the truth. So this is based off of 99%. Wants to be within 2. So our margin of error should be 2 units of the truth. How many people should be included? Okay? How many people go to your... How many people should be sampled? Go to your formula sheet, go to sample size. Now, he wants to estimate the average BMI, so that's why we know we're going to be using the sample size calculation for mean. Alright? So, n equals z alpha divided by 2, sigma over e squared. Okay? Now I need to figure out what the critical value is for 99% confidence interval. It is one of the ones that they give us in the cheat down here, so I'll go ahead and use that. Okay, 2.575, okay, times 3.2 divided by E. He wants to be within 2 units of the truth. Take all that and square it. Okay. So let's go ahead and figure this out. 2.575 times 3.2 divided by 2 and square that. I get 16.97. You always round it up, even if it was 16.07, still round it up 17. Okay? So he needs to sample 17 people. Alright? At least 17 people in order to calculate that average BMI. Alright. Moving on to the next question. Gas mileage in miles per gallon was measured on 6 Hummer vehicles. Assume the population is normally distributed for gas mileage. Okay, so below are the results. Constructing 90% confidence interval. So I'm doing confidence interval now for the population mean. If I go to my thing here, doing confidence interval, okay, for a mean. Alright, so is sigma known or sigma unknown? In this case, sigma is unknown, right? They didn't even calculate the mean for us. All they did is give us data. It's a small amount of data too, so once I calculate the sample standard deviation, I'm not going to be able to assume that it is equivalent to the, or close enough to the population standard deviation, because my sample size is so small. So let me go ahead and write down my formulas here. Right, same formula as up there. Okay. But now I have T for my margin of error, and I have S instead of sigma. So sample standard deviation instead of population standard deviation. Alright, so now I need to calculate some means and stuff, right? Let's just calculate this. Sum up all this data, divided by 6. I did that, I got 13.1167. Find the sample standard deviation. Now, if you're out of practice, this is stuff that we did during exam 1. Okay, so if you need to go back and refresh on how to find sample means, how to find sample standard deviations, highly recommend that you do that. If you don't want to get a 0 on this question, because you don't remember something from test 1. And I highly think that there will be a question like this on the exam. So it's a very good idea to go back and refresh on how to find sample standard deviation if you're unsure about how to do that right now. Alright? So you figure out sample standard deviation here. Right? I get 0.6998. You guys go ahead and double check that. Alright, so now I need T alpha divided by 2. Before I can find the T, I need to figure out what my DF is. Remember, DF is n minus 1. In this case would be 6 minus 1, which is 5. 1, 2, 3, 4, 5, 6. Okay? Now, what percentage confidence interval? It's 90%. Which means that the area in both the tails will be 0.1. Right? Because 90% means 90% in the middle and 0.1 left over. 0.9 in the middle, 0.9 in the middle, 0.1 left over. Okay? And my degrees of freedom is 5. So my T is 2.015. Okay. Plug things into this formula here. Don't forget that is N, right? Okay, so this is the original sample size. Very common mistake is to have 5 in there, 1 minus, so because you figured out the degrees of freedom, but that's actually sample size there. Second square root of 6. Okay, plug that into your calculator all at once, and you should get 0.5. Okay, so that's my margin of error. 0.5757. Okay, so then I'll do 13 minus 0.5757, and then 13.1167 plus 0.5757. Okay, so 13.1197 minus, use the answer, previous answer, okay, 12.54. Okay, then do 13.1167 plus the margin of error, 13.69. Okay.